Hello everyone and welcome to the interview session here at Planning Engineer Academy GCC, and I have created this channel to help aspiring planning and site engineers, QA/QC engineers master the technical knowledge required for the top tier interview in the GCC region. So in this series we are not just see the definition. We are looking at the practical standard used on the side. Today in class second, we begin with the absolute essential. So let's see uh, duration of the concrete. So for how many days should a concrete structure be cured? We say like that. So it is the curing period is 7, 14, and 28 days. However, I have not mentioned here 28 days. So typically curing is done for 7 days. Okay, for a specific cement like PPC, Portland cement, a longer duration of 14 days is recommended since the this PPC is not take strength in short period. Okay, so it's take time to form in strength. Okay, so that's why normally we use OPC cement in company or any residential or commercial building. Mostly we use OPC since it's come in it's started to comes in strength after 35 to 45 minutes. Okay, so you have to just remember curing period is 7 to 28 days, 28 days, 7 days, 14 days, 28 days. Okay, plus 28 days, I forgot to mention here 28 days. Okay, so let's go to the second slide. Like your interviewer can ask you, make me understand what is the hydration. How will explain? This is the very technical word. Hydration. What is the hydration? You can see here. What is the technical definition of hydration in concrete? It is very important that one of my interview asked about this hydration. Actually, I explained about the hydration, but I could not explain hydration in very technical way. Okay, so it is very useful. So you just remember. Hydration is the chemical reaction that occurs between water and cement. The process forms a new compound that binds the material together to create solid concrete. Okay, this is the hydration. When hydration starts, this is the bag of the cement. Okay, cement bag. So once this cement comes in touch with the water, the cement hydration start. Okay, so it started to forms in strength. So this is called the hydration is the chemical reaction. Since the chemical is there in the cement, and once the chemical comes with attached with the water, so it started the hydration. Okay, so you have to explain like that. Application of curing membrane. Okay, that the simple question that interviewer can ask you, how many times should a curing membrane be applied? So normally it should be applied at least twice. Matlab, at least 2 times we should do the curing. But it is not like that. In many cases, if the temperature is too high, that if the weather is too hot, if that it's a very hot season, so this hot season will not at least twice. We do the pounding curing, as I told you in my first video interview session, that for pounding curing. This is the slab, so we just do here one layer brickwork, and we put the what's called this water on the slab for at least 1 week. Okay, but if the weather is cold or rainy season. So in that season, that two times is okay. So you have to just explain with the term, sir. That normally curing should be done at least two times. But if the weather is too hot, so we'll do the pond curing. Pond curing. Okay, so you have to remember. This is very important. Water quality for curing. See that how water quality should be. The water should not be salty. Water TDS level should not be more than 1000 ppm. Okay, so this is the very important. Okay, what is the limit? See, you can see here. What is the limit for total dissolved solid? Means to TDS. We means say in short form TDS in curing water. So the water used for curing should not contain more than 1000 ppm. Okay, clean water ensure the chemical reaction is not contaminated by salt or any mineral. Since the water comes in touch with the cement, this is the chemical reaction. So if the water is contaminating with the salt and mineral, so both that reaction will come from both sides, from this side also, from this side also. So this concrete will not comes in the strength. That concrete will not achieve the target compressive strength. So you have to just remember. Let's go to the safe concrete pouring height. What is the maximum height from which concrete can be dropped freely? What is this? The concrete can be dropped from a height up to 1.5 meter. And why? I'll explain you. First you understand what is this. What is the maximum height from which concrete can be dropped freely? See, this is the slab. This is the slab surface, and this is the pump hose pipe. This is a hose pipe. Okay, concrete coming from the pump. This is the hose pipe. Okay, so this concrete is coming from here to here. This height should not be 1.5 meter. This is a hose. Okay, so this height should not be 1.5 meter. Why? The 1.5 should not exceed. Why? Dropping it from higher than this can cause segregation. Segregation means while this suppose this hose pump is 2 meter at 2 meter height from this slab surface. So while this concrete dropping from here, segregation will be happen. Segregation means concrete will go here, concrete will go here. I mean to aggregate will go here. This is the aggregate. Aggregate will go here. That slurry will go here. So it will not that bonding, that strength will be less. It will not come in bonding. Say suppose that aggregate is going somewhere else, and so this is called segregation. So in concrete, segregation should not be happen. Since if the segregation happen, then honeycomb will come. Okay, so you have to just remember. So if your interviewer is asked like that, so you can say or you can explain. Uh, this is 1.5 meter. Okay, actually I explain in very simple language that anybody can understand these things. Okay, whether he's a supervisor, foreman, or whoever. Okay, so this is the reducing the water cement ratio. For reducing the water cement ratio, we use that plasticizer. Already I told you, na, that so how will reduce? I'll tell you. What are the advantage of using a lower water cement ratio? Water cement ratio already I told you in my first lecture, then in my first series, in my first video, that I'll explain you what is the water cement ratio. I will give the formula. I will do everything. And you can understand what is the water ratio. Okay. So that water ratio, advantage of using a lower water ratio is higher compressive strength and increase water tightness. Higher compressive strength and increased water tightness, lower absorption, better resistance to weathering, and a strong bond between the concrete and steel reinforcement. Okay, so the higher compressive strength and increased water tightness. So you have to just remember. Basic type of concrete. What are the two primary category of concrete used in construction? Used for load-bearing element like beams and columns. The structure concrete, non-structural concrete. See that concrete is divided in two category. Okay, two primary category. This is two primary category. That what is this? Used for load bearing elements like beam and column. So we use grade M20 to M60. After M20, already I told you after 125 for 150 for 130 we'll do the design mix. Okay, so in some places in local structure like in village or in local places, some people use M15 also. The slab thickness is 150, 125 mm. But it should not be like that. Actually, we should not use the grade. Uh, we should not use concrete less than M20 grade. Okay. Um, what is M20? M20 grade ratio is what? 1 cement, 1.5 sand, and 3 aggregate. This is the ratio of the M20. Okay, so just remember. And then, so this is for the structure concrete, that grade. But in some place, we use for element that do not carry heavy loads such as a lean concrete or flooring. In say, lean concrete means what? Lean concrete is the PCC, plain cement concrete. We use we use before the footing. The this is the footing. I think I'm taking much time. I don't want to explain this much. This is the footing. Okay, so you don't see my this pointer, all the things, since I'm this actually I write by mouse. Okay, so this is the footing, concrete footing. Okay, this is the footing. So we do here PCC first. This is the PCC. We takes offset for 100 mm, 800 mm. Okay, so this is the PCC. So this element is it's not structural concrete. Okay, so for this PCC and flooring, sometimes we do the flooring. So for that we use the non-structural concrete or non-structural concrete. So that ratio is M to M5 to M15 for PCC. Mostly we use M10 PCC. Lean concrete is a PCC. You have to just remember. Some people is confused with what is the lean concrete and what is the PCC. So they both are same. Some people say lean concrete. Some people say this PCC. Okay, so you have to just remember. Okay. So second is concrete strength development. How does the 7 days strength compare to 28 days length of the concrete? Okay, so we say at 7 days, concrete typically reach 75 to 75. 70 to 75. 7 to Okay, in 7 days, 70 to 75 days. In 14 days, we achieve our strength. We achieve our strength 90%. Okay, in 28 days, we achieve 100%. You have to remember. Interviewer may ask you. Done? Let's go. Let's go to the second non-composite structure. What is the non-composite structure? What definition in non-composite structure? It is, you can see here. It is a structure built using only one material, either